Today I'm going to show you about angles and sine and cosine on a ramp. First things first, we have to figure out which angles are the same. Notice right here, this iPad shows the angle of this ramp is around 32, 33 degrees, which is this angle right here. Let me prove that by lifting it up. Notice the angle is going down because it's becoming flat, and the angle again is at roughly 32 degrees. Well, notice here, and you'll have to move in to get this nice and close. You see that right there? Go ahead and zoom in. That right there says 30 degrees, so it's somewhere between 32 degrees, something like that. Now, you're going to back out over here if you can, and look at this angle and that angle, let me go over here, as I lift the ramp to show that they are the same. Angles are closing. The thing is going to flat. Angle is increasing at the same time. That one's getting stuck there a little bit. So, when you're doing a ramp problem, this angle, move that out a little bit so it hangs a little bit better. This angle here and this angle here are the same. That's the first thing to notice. Second thing, and you're going to have to zoom in here, get close to where you can see that that says a little over 3 newtons. That's the weight of a cart. I have an identical cart that's on the ramp, and you'll notice it's a little over 1.5 newtons. Now you should know already, or hopefully you know, that the sine of 30 degrees is 0.5. Well, this is very close to half. Okay, if we worked out 33 degrees, and also that may not be calibrated actually. So notice, I want you to zoom in on this, and I want you to notice what happens as I reduce the angle. You will see that the force is decreasing to 0 when the ramp is at 0 degrees. And you should notice, there it is, the ramp is 0 degrees, and you should know that the sine of 0 degrees is 0. So, that's why when we are doing a ramp problem, the force down the ramp, we use sine of theta, where this force is actually mg sine theta, where this angle and this angle are the same. But what about the normal force? Let's look over here. I can't show it on that ramp very easily, but I have a scale. Notice that my iPhone is somewhere around 170 grams, and watch what happens as I tilt it. Notice that the weight, or the normal force, which is what the scale reads, has gone down. If you use your calculator, you should be able to find out that increasing the angle, cosine decreases. Cosine of 0 degrees is 1. Cosine of 90 is 0. So, on a ramp problem, down the ramp is mg sine theta. The normal force is mg cosine theta. This angle and this angle are the same. And just because I have you here, let's go ahead and look at this one more time. If you'll get close up, I'm not sure if this is going to be easy to see or not, but that reads the weight of the object. But if I have it swing, you can see how that goes heavy. It seems to be heavier, or it makes the spring elongate even more. And the reason for that is because now it's not just holding up the mass, it's actually having to accelerate the mass circularly, having additional force for that acceleration. Thank you.